Hello and welcome to Advanced Hunting in Defender and Sentinel. So we've spoken about creating queries for hunting in KQL. So let's speak about searching for endpoints, communicating with a specific domain. And this is our example. There's the query. We let domain equal something. So let's go ahead and check that out. So we were speaking about searching for endpoints communicating within a specific domain in Defender. So here we are in Advanced Hunting in Defender. We can just paste that. Yes, we would allow. Okay, we can do that once. Okay, so here's the query that we're looking at. We're letting a domain equal something. So this actually, just be careful for syntactical errors like this. You can do that like that. So if I go ahead here and I look at assets and the devices here, I can see that I've got a domain controller and an actual machine, Windows 10 machine that's connected here. So I have two of them. I have two machines that are connected here, this one and this one. So if I go back into Advanced Hunting, and I'll just go ahead and paste that query and watch out for syntactical errors. You can do that. And then I can actually change this over here to this. Watch out for these little syntactical errors. And let's go ahead and run this query. So that query is running. We can see that we can change the time filter here. We can take it out of the query. So there's been nothing in the past 7 days you can see this works really well inside Advanced Hunting. Let's create a new query here inside Sentinel, and let's see. Okay, it doesn't have device network events. So what you can do is you can go and research what exact table in here is the equivalent, but let's jump back into Advanced Hunting in Defender. So that is looking for any device network events. So those were endpoints communicating with a specific domain. Okay, the result will show that all endpoints that are communicating with a specific domain. If the domain is being confirmed as being malicious, then every endpoint that is connected with the domain can be considered an infected endpoint. So detect invalid password failures across multiple applications for the same account. We can go ahead and we can perform this. So let's go ahead and query for scheduled tasks. So we can go ahead and we can just paste this command in here. Just remove that. Watch out for syntactical stuff. We can go ahead and run that. We're looking against all device process events. This is set in query, but we can actually remove that completely, and we can say, let's just say in the last 30 days, the longer that you set this time period, the longer that it's going to actually take to run. And it's telling us that no results were found in the specified time frame. So that's searching for created scheduled tasks in Advanced Hunting and Defender. So malicious documents, macros that try to connect to a suspicious domain or website. So this query will identify any malicious documents that have been used to connect to a malicious domain. So it's quite a long query. We've done this before. We've actually gone through this in module 4, so I'm just going to skip it for now. There's multiple ways of doing it. You can go ahead and run that inside Defender or Sentinel. Okay, there's the March attack TTP is T1059.005. So you can, as we've done before, search for a malicious document that executed another program or spawns a process. So we've been through this before. There's the March attack TTP. So search for PowerShell execution events that can involve a download. Let's go ahead and try this one. So here the entire query is inside Advanced Hunting and Defender. So we've used the union keyword. We've done quite a lot of things here. We're looking for PowerShell execution events. It's set in query. We can remove that, and we can take a look at the last 30 days, and we can see what's happened. There definitely has been some PowerShell events that have, I'm pretty sure that I've created some. So let's just see what the results give us here. And as we can see, we've had a lot of PowerShell events. So I've been intentionally running a lot of PowerShell on both the virtual machines that are connected to my instance of Microsoft, and it shows you what's happened here. This is legitimate stuff, plugs coming from the Microsoft themselves, and then it's got basically all the columns. So you'll see there's a lot of columns: timestamp, device ID, device name, action type, folder path. There's SHA-256, SHA-1, there's even MD5 hashes. There's a lot of stuff. So the searching for PowerShell events that could involve a download, this works very well inside Microsoft Defender Advanced Hunting. Okay, search for all PowerShell processes or scripts that execute another program. We won't run through that one. We've done that already. So search for all programs that loaded an unsigned DLL library from DLL or DLL from temp. So this query aims to identify suspicious DLL injection by checking for unsigned DLL loaded from temp or used in public. So we create the device image load events, and it's a whole quite long command. There's the reference. Okay, moving along from PowerShell, you can use that reference. Search for a program that executes another program or process from the temp directory. Okay, so this query can be used to find any processes that have been executed from temp or CU's public folders that are commonly used by attackers. So let's go ahead and try that. So we've got that query. We can go ahead and run it over the past 30 days. And we can see that there are actually device process events where actual processes were created out of temp. And there is a cleaning manager. There has actually been incidents. That gives a timestamp. It gives the name of the machine that's a VM that's connected here. So there have been some positive results for this device process events in this query. Okay, this is just explaining results to you. So search for a program that executes another program from or process from the temp directory. So search for malicious top-level domains that have been executed. So you can search for any suspicious top-level domains that any machine is connected to. This will help in identifying malicious activities in your organization. So you can specify whether the remote URL ends with here's TK for Turkey, CC for China, DK for wherever, RU for Russia. So that's specific to where you are in the world. And remember that your cyber threat intelligence is going to guide you with that. So that's continued searching for malicious top-level domains that have been executed. Okay, same thing. There's the March attack TTP. You can go through it your own time. So search for all domains that have been contacted by process, given its name or PID. We've been through this before. We've been through this in Module 4. You just specify the PID, and it'll query the device network events table in Defender. Okay, and the results will give you that. So search for domains that have been contacted by process, given its name or PID. Remote URL, it's just an explanation of what your results are. So you could search for processes which execute a specific program based on its hash name or path. Also, we've been through this. You're querying the device process events table, and you're looking for a type of SHA-256, MD5 hash, etc. Okay, we've been through that before. That was quite interesting. So how do you disable Windows Defender from the command line in PowerShell? So attackers will be using any one of these techniques that they'll be able to disable Windows Defender from the command line. So remember, we've been through this before in depth. We're looking for processes that tried to dump LSAS. So we've been through that in depth. Hunting for async rat deployment. This is just an example of you may want to research async rat and see which threat actors are using it. You'll do CTI for your organization specifically, and you'll decide what to hunt for. That's for async rat. So hunting in KQL, we've been through that. Detecting partial events, we've been through that. Detecting lateral movement with PSX or Windows Management Instrumentation, we can do that. Detecting basically credential dumping or SAM access. So this is simple. This is just device process events, and you're looking for that, right? Very, very easy. So this is the most simple way to search for credential dumping. Suspicious use of RDP, so you look at device network events, and you're just looking for all instances of RDP, see if they're available. Searching for suspicious documents spawning another process, we've been through that. Partial events that could involve a download, we've been through that. Okay, partial scripts, we're not going to rehash that. DLLs, we've been through that too. So this is all good for you to go through in your spare time. We've been through that. Specific PID, specific hash, we've been through. File path, we've been through. LSAS, we've been through. All commands. Okay, now let's look at the interesting stuff here, which is for Active Directory. Take a look and see whether this works better inside Sentinel versus Defender. Okay, looks like we're looking at the same tables that are existing in Sentinel. So let's just carry on. This is a very long command, so just be aware of that. So this looks like it's going to do that, and then we query target. So you can just do exactly the same thing. And it looks like this is legitimate. It looks like it's going to run. It's set in query. So there's basically, this is in Microsoft Sentinel, so only a Windows 10 machine is running in Microsoft Sentinel. What you can do for yourself is you can actually see how to convert this into a query that'll work inside. So this is to identify logon events. So let's just go ahead and run the query. And no results were found. Let's go back into our notes. Okay, so find processes that send SAMR queries to Active Directory. So Security Account Manager Remote Protocol is client to server, provides management functionality for an account store directory containing users and groups. The goal of this protocol is to enable IT administrators and end users to manage users, groups, and computers. So there it is. Let's just get into our Defender. Okay, so we've put that entire query here. We can run the query in advanced setting. It's telling us, let's just say run query. We can expand upon the query. So it says that it's telling us that no, if the results are found. So let's just check how well the same query works inside. Okay, so there's a few issues inside Sentinel, but my domain controller is connected to Defender, so that's where we're looking. It looks like this command is running really nicely here. Okay, so that was for SAMR queries. So AD service account remote logon. So this query aims to identify successful login remote through RDP for a service account. If there's a naming convention for your services, e.g. starting with SVC, you can use this query to identify them. So I'm not going to go through that. Detecting password spread attacks. So password spread attacks are a common type of password guessing attacks, which an attacker tries to define passwords on numerous accounts within an organization. This query leverages the aggregation features of KQL. So AD service account remote logon. Then passhash is an attack that enables the attacker to log into a machine using a compromised user account name, account username, and the NTLM hash of her or his password without the need to crack the password. So there's quite a long query. We're not going to get into that. Let's talk about Kerberos. So Kerberos delegation allows a service to impersonate a user to access another resource. Authentication is delegated, and the final resource responds to the service as if it had the first user's rights. There are different types of delegation, each with weaknesses that may allow an attacker to impersonate users to leverage other services. So you can go ahead and search for unconstrained delegation. Search for unconstrained delegation. So that's a Kerberos attack that'll work in Defender. Well, I hope you've enjoyed this session. I hope you enjoyed practicing attacking Active Directory. And bye for now.